Welcome back to our series on mathematical statistics. I'm Mark Ledbetter. This is video 24. We are in lecture 11. This is part A of that lecture, and we are in part 2 of sufficient statistics. So previously, we talked about the definition of sufficient statistics, and we followed the definition that the book uses, the factorization theorem. It's a very smart way of making things a little bit easier for undergraduate students. The factorization theorem is a very big bonus for those of us who have to use this in proofs. So we're going to talk about the sufficiency principle and hopefully the exponential family of distributions. So last time we stopped before we got to example 2. So that's where we're going to start now. Let x1, x2, xn be a random sample from a normal distribution where the mean is mu, unknown, and the variance, recall that the number here is sigma squared, and the variance is equal to 1. This is a very simple case for the normal distribution. It makes finding the sufficient statistic a lot easier, as we'll see when we do multiple parameters. So the first thing we want to do is find a sufficient statistic for mu. We need to find the joint PDF of x1, x2, up to xn. Okay? And so this is going to be, because these are from a random sample, remember that xi, the observations, are IID, normal, IID, that means identical and independently distributed, mu 1. Okay, so every single one of them have the same distribution. And since they're independent, we find the joint PDF the easiest way possible by taking the product. If we do not have independent distributions, we have to use conditional distribution to find the joint PDF, a very long route to take. So this is actually a simple case method. When we have a random sample, we really like having to solve that rather than the other cases. Fortunately for you in this course, this is the only case we're going to deal with. So we're going to keep it as simple as we can, but still get the idea, I hope, across to you. All right, so the joint PDF, f of x1 up to xn mu, is equal to the product of f sub xi mu, I equals 1 to n, which is equal to the product, I equals 1 to n, of the normal distribution PDF. So remember that if x is a normal mu sigma squared, then f of x is equal to 1 over sigma square root 2 pi e to the negative x minus mu quantity squared over 2 sigma squared. Okay? So now sigma squared equals 1. And that implies that sigma is equal to 1. We can actually say if and only if, because sigma can't be negative in this case. So since it's a standard deviation, that's always positive. Okay? Because of that, this can be written as 1 square root of 2 pi, and that's in the denominator, e to the negative xi minus mu squared over 2 times 1 squared, or 1. Actually, I don't need to do the square there. So 1, because 1, we're saying that sigma squared is 1 by definition. Okay. So this is equal to the product of 2 pi to the negative 1/2 e to the negative xi minus mu squared over 2. I equals 1 to n. Now, when we take, there's no need to break this up. We can leave this because it's a constant, and so we're not that concerned with it. It can, but we do have to raise it to the nth power since it's a constant and there's no indice. There's no sub I anywhere in the 2 or the pi. So there's going to be n of these multiplied by themselves, and that is 2 pi to the negative 1/2 raised to the nth power. And then Remember that we have e to the negative x sub 1 minus mu squared over 2, e to the negative x sub 2 minus mu squared over 2, and so forth, e to the negative x sub n minus mu squared over 2. And so we add the exponents. The exponent portion is negative x1 minus mu squared over 2 minus x2 minus mu squared over 2 minus negative x minus mu squared over 2. They have a common denominator, so we sum the numerator, not the denominator, right? When we have a common denominator, we can just put the whole thing over 2 in this case. So this is going to be e to the negative sum of xi minus mu quantity squared over 2. All right. And I'm going to get rid of the explanation here. That is not something you need to show when you're doing the problem. You can do that on the scratch paper, okay? And so I can then write this as 2 pi to the negative n over 2, all right? And I'm going to change this to make it easier, exp, and I've got negative sum of xi minus mu quantity squared over 2. Now, we're going to rewrite the first, which is 2 pi to the negative, or I'm sorry, there's no negative out in the front. But it's negative n over 2. exp to the negative, now I can pull the 1/2 out to the front, so this can be written negative 1/2, and then I can do the summation, and then I'll use parentheses x sub I minus x bar plus x bar minus mu, okay? And then quantity squared. And now I'm going to group this first one and the second one. So both terms have x bar in them, okay? Both terms have the x bar. And so I'm going to rewrite this as this, and then put another bracket here, okay? So this bracket goes with this bracket, all right. And then the inner brackets go together. So now that I've grouped those together, when I square this, I'm going to think of this as like A, and this is like B. And so A plus B squared is equal to A squared plus 2AB plus B squared, okay? So that's how we're going to do this, using our algebra that we know, I hope. exp, negative 1/2, and now we have the sum, and we have another bracket, and we'll have xi minus x bar quantity squared plus 2 times xi minus x bar times x bar minus mu quantity plus x bar minus mu quantity squared, end of the bracket, and this, so then we have here. Okay. Now, we're now going to distribute the summation sign across the addition. All right. So this becomes 2 pi negative n over 2 exp negative 1/2 sum of xi minus mu, or x bar, sorry, quantity squared plus 2 times the sum of xi minus x bar minus mu plus sum of x bar minus mu quantity squared. And we have one bracket, two brackets. All right. So now we can simplify these summations. exp, there is absolutely nothing I can do to this first summation because there's a sub I in this term inside the square, and I do not want to expand that square. There's nothing that will really simplify nicely that way. So I'm just going to leave the first term. I was missing a bracket here. Here's the bracket that goes with this one. Okay, so these two go together. And so I have this first summation, so I'm going to put my bracket back here, xi minus x bar quantity squared minus. Now, this term does not have any subscript, no sub I in there. Okay, there's no little I, and we are summing across I equals 1 to n. Okay, I equals 1 to n. So since this doesn't have any subscript, I can pull it out to the front of the summation, but I cannot do this first term. So this is going to be 2 times x bar minus mu, sum of xi minus x bar, okay, plus, now, this again is a constant. This is x bar, which is a constant, minus mu, which is a constant. And so for that sample, x bar is a constant. Okay, so for the one random sample that we have, then this whole thing, I'm going to have n of these. So this is going to be n times x bar minus mu quantity squared. And then I have this bracket and the second bracket. Now, I equals 1 to n. I have x sub I minus x bar. This can be expanded. I'm not going to include this permanently, but this is xi minus sum of x bar. And so this is sum of xi minus n times x bar. If I substitute in for x bar, I have sum of xi minus 1 over n times n. I'm sorry, I'm doing that in the wrong order. I have n times 1 over n, sum of xi. And so this n and this 1 over n, they cancel out, become 1. And so I'm left with sum of xi minus sum of xi, that's 0. Oops. So this term, so again, I'm showing you this over and over again, hoping that you remember that, or that you've written it down on your formula sheet somewhere, so that as soon as you see this, you know this whole term goes to 0 in the middle. Okay? And so we're left with 2 pi negative n over 2 exp bracket negative 1/2 bracket sum of xi minus x bar quantity squared plus n x bar minus mu quantity squared. Okay. Now, remember that this is 2 pi negative n over 2 e to the negative 1/2 times the sum of xi minus x bar quantity squared plus n x bar minus mu quantity squared. Okay, in the exponent. And when we add exponents, it's because we have multiplied something. So we can break this up. We can go in reverse. Remember that e to the a times e to the b is equal to e to the a plus b. So I can go this way, or I can go this way. I'm going to go this way this time. Okay. And so yes, this is a tricky problem. That's why we're doing it as an example and not as a homework problem, like in some courses. Negative 1/2 sum of xi minus x bar quantity squared e to the negative 1/2. Don't forget that you have to distribute this. N times x bar minus mu quantity squared. Okay, and then so that is there. And so now, by doing this, we need to use the factorization theorem. Okay, so this is going to be phi of x bar. Oh no, I need to rearrange. I need to get my rearrange this. Just put it in a different order. I have a function of x here, okay, and the parameter mu. Here, this is only a function of x only, x sub I and x bar, x only. So I'm going to put e to the negative 1/2 sum of xi minus x bar quantity squared times 2 pi negative n over 2 e to the negative 1/2 sum of xi minus x bar quantity squared. This is my h. Now, this constant can go with either one. Since it doesn't contain an x and it doesn't contain a mu, it's really up to you which one you want to put it with. It's really immaterial. It does not matter. Okay? It's a function of n only. So it can be in either one of these. All right? So there is not just one right answer for this. There's two. So now, maybe I'll leave this as green. So this is now phi of x bar, and oh, I'm sorry, I've written it in. Yeah, I wrote this wrong, didn't I? This is supposed to be. I wrote them both. I did not switch what I was supposed to. So let's rewrite this. I was too busy talking and not busy enough paying attention. Minus 1/2. So n over 2 x bar minus mu quantity squared. That's another way to write this term. Okay? And so that is phi of x bar mu. And this is h of x1, x2, up to xn only. It's only a function of x. Okay? Why did I include the constant with this one when I have a choice? Because sometimes you will only have the constant. And if the constant is the only thing you have here, then it is h. Even though there's not an x there, we say that it's x to the 0 power, and so therefore a function of x. So I put the constant most of the time, unless it makes something easier for some reason. I put the constant with the function of h. I make it a part of h because sometimes the constant's entirely h entirely. It's the only thing that's not a function of mu. So anyway, we may get to one of those. So notice that the function, that phi is a function of x1, x2, up to xn only through x bar, which is 1 over n sum of xi. Okay? Therefore, y equals x bar is a sufficient statistic for mu by the factorization theorem. Now, this part is important. Anytime you use a theorem in a proof, and every one of the problems in this section is a proof. So every single one of these problems is a proof. Just please get that into your thoughts. So every time you tell me what a sufficient statistic is, you have to tell me how you got there. So far, all we've used is the factorization theorem, so you need to say by the factorization theorem. We're going to learn some other theorems in this section. So you need to be explicit and tell whoever's the reader, in this case me, that you're doing this, that you found this statistic by the factorization theorem. Okay? Now let's look at B. What was part B? So part B asked, find a power of the sufficient statistic, which is also a sufficient statistic of mu. Okay? So, now, we need a one-to-one function. Let W equal x cubed. is a one-to-one function of x bar, okay, which does not involve mu. So W is a one-to-one function. Therefore, x bar cubed. Now, I can't use x bar squared because x bar squared is not a one-to-one function. It's a two-to-one function. But any odd power, I could have chosen any odd power to raise it to. It could have been x cubed, x to the fifth, x to the seventh, etc. Those are all going to be sufficient statistics for mu. So therefore, x bar cubed is a sufficient statistic for mu. So as is x bar to the fifth, x bar to the seventh, and so forth. Okay? Okay, that's it for this video. So please update your formula sheet if you haven't already. And if you have questions, come to virtual office hours. If you need help before office hours, please email me. When you email me, make sure you send me a picture of the problem, picture of your work so far. That way I can help you efficiently through email. Or if it's a different type of question, just make sure that it's adequately explained so I know exactly what you're asking, and then I'll get back to you as soon as it's possible for me. Please stay safe, take care of yourself, because we hope to see you next time.